Hi, Srivalli.
Hi, Shanti.
So today's demo is on healthcare insurance claims solution design steps, right?
Yeah.
Okay. Right. You please go ahead.
Hi, I'm Srivalli. I have about 16 years of experience in IT industry. My latest experience being at Microsoft Redmond. Today, I'm here to talk about healthcare insurance claims prediction model, design steps, solution design steps, as part of my job coaching for Azure DevOps and um, generative AI. Let's begin with the agenda. So first, we'll just go through in general, what the activities are with the healthcare domain. And then we'll talk about a high-level workflow of how claims processing happens today without the ML model. And then we'll go ahead and talk about what claims adjudication process is. It's a main activity during the claims processing. And then role of ML in claims adjudication. And we'll visit three main areas in the workflow where ML can help. Um, in claims adjudication, claims filing, and denial management. And then we'll go over a chart for high-level understanding of justification of implementing claims prediction model, which is the machine learning model, and then predicting claims approval likelihood. So this is the business requirement discussion for ML model implementation. And then we'll discuss about what the acceptance criteria would be um, from business point of view. And claims prediction model with Azure ML. Those are the next two discussions we will have. The first one is just a high-level ML model, and then the second one is the model implementation on specifically on Azure ML. And then we'll discuss the various parts of this implementation. The various parts are data pre-processing, feature engineering, model training development, model deployment, model monitoring, and then finally we would see what the key takeaways are. That's the last slide that talks about key enhancements using the claims prediction model. Okay, to begin with, healthcare domain, what are the major activities, or in general, what activities are present in healthcare domain? Patient care and clinical services. It focuses on diagnosing, treating, and managing patient health conditions. And then there's the administrative and operational activities, which is common for any industry, right? Administrative and operational activities. And then healthcare resource management. Healthcare resource management is, let's say, during peak flu season, or let's say during when there was COVID, someone has to make sure the beds are available, medical supplies are stocked, and equipment is available for such large scale, so scalability issues. Um, and then someone needs to have a good idea of what the optimization um, uh, what are the optimization strategies. So all of these are managed by healthcare resource management. And then comes the medical research and development. Of course, in the medical field, there is research and development always going on for the new medications and discovery of new uh, flu strands. Public health and population management. And then lastly, there's financial management in healthcare. Now, this is our area of discussion today. Under financial management and healthcare, we have claims management. One of the areas is claims processing and revenue cycle management. And there are other areas, but majorly these two areas. And our presentation today is mainly focused on claims processing, how we can streamline and optimize claims processing using an ML model. Let's see what the high-level workflow is. Patient registration and insurance verification, and then charge capture. This is the hospital bills. It could be the hospital bills that's captured, and then claims filing. Now, based on all of these paperwork, someone has to manually check these paperwork. I'm thinking there's a manual work partly and partly automation work that does these tasks. And then there's going to be, when all of the documentation is intact, there's going to be claims filing and claims adjudication. Claims adjudication is the process where someone goes through all the claims documentation and then makes a decision whether to accept or deny the claim. Now, if the claim is not denied, then the payment is posted. This is just straightforward. But if the claim is denied, then there is going to be denial management. That's a whole separate workflow of denial management. And part of it involves the reprocessing, the user or the customer appealing for reprocessing, and then the reprocessing happening. So that's all in the denial management. And then if the claim is not denied, then it's a straightforward process: patient billing and collections, and reporting and analytics. Let's talk about one of the major tasks in the workflow: claims adjudication process. What does it involve? It involves eligibility verification, medical necessity review, and payment determination. Initial review, that actually comes first. There's going to be an initial review, check the completeness and check the accuracy. Here we are talking about the documentation, like the bills and also the diagnosis, whether they are accurate or not. And then eligibility verification is what kind of coverage and who has provided the services, whether they are in the network or not in network. So those are some of the things. That's the eligibility verification. And medical necessity review is whether someone had authorized this procedure, and was it really necessary? But maybe there was an alternative. Maybe there was a drug that could have been used instead of a procedure, right? And then payment determination is sometimes there's only partial payment. The user is eligible for partial payment, and sometimes the user is eligible for full payment. So that's that. And role of ML in claims adjudication. Okay, so reducing the turnaround time. ML optimizes claim processing by predicting the fastest path to approval, right? And then there could be various paths that can be taken when a claims is processed. Some of that is manual and some of that is automated. But if you are using an ML model, it is fully automated and it takes the fastest path, and it determines that based on the past history. And then improving medical necessity determination. This also can be automated. Let's say, for example, someone went through a knee surgery. An ML model can review past claims that were approved for that surgery, and it can flag the likelihood of this claim being approved and score it, whether it's highly scored or not so highly scored, right? And then predicting the denial. So it's the opposite of what we just talked. Let's say the ML model can review the past history data and then can predict whether there is a likelihood of denying a claim. And then fraud detection. Fraud detection is So a large data set can be analyzed. That's the past history that can be analyzed, um, and flag suspicious claims more effectively, based on how some of the past claims were rejected, or how the past claims, the fraud was detected in the past claims. Um, when you automate these things using a regular software development, there could be some rules that got missed, or there could be some complexities or some specifics that were missed, or that were not included in the algorithm. But ML is designed to learn based on the uh, past data. Automating initial review, detecting patterns, flagging incomplete information. So this is similar. This is also the same thing, but based on how a particular claim was denied because something was missing, or some documentation, some piece of documentation was missing. Um, and then speaking about ML in claims filing, how does it help? It reduces the rework and rejection rates. And then ensuring compliance with complex rules. As you know, in the medical field or in the healthcare industry, there's reforms always happening and the rules keep changing. So compliance with the complex rules means changing the software whenever there is a reform, whenever there is a reform. So changing a software is much more tedious process. Someone has to change the code and then deploy it, and then the change has to go through the deployment pipeline and all of that. Instead of that, when we have an ML model which is trained on the data, it can learn based on the new data that is coming in to make an informed decision. Data entry accuracy, there could be real-time corrections. Someone has entered something wrong on a form. The ML model can auto-correct them based on the past history. And then reducing processing time, automated reviews, instant discrepancy flagging, improving payer-specific filing, customizing formats, and then improving approval rates, and enhancing claims prioritization. Um, yeah, so the claims that are urgent can be easily flagged. It's the same thing based on the past history. And then predicting likelihood of approval, or it's the same thing like denying or approving. And then automating document validation and classification. Um, and then handling large volumes of claims. So this is the scalability solution. Um, when compared to a regular scalability using the resources in the DevOps, this is more effective because ML ops has proactive scaling than reactive scaling. Role of ML in denial management. Um, and then we already talked about continuous improvement under this. So the continuous improvement is also applicable here. Um, the chance of getting a claim denied because some policy has changed or because some reform happened is lower with ML model, because ML model is designed to make a decision based on the new data or the new rules. Pattern recognition and predictive analytics, and then scalability and efficiency, process large volumes, handles complex scenarios, proactive denial prevention. So rather than having a reactive denial prevention, so rather than going down the workflow of rejecting a claim and then someone filing a reprocessing request, and then going through the reprocessing again. So proactive denial prevention is based on predictive analytics. ML model can proactively flag if there is a high chance of false denial. And dynamic learning and adaptability adapts to new patterns, less manual intervention, of course, because the ML model has the capability of learning based on the data and reduction in human error. So here, human intervention is reduced much more when compared to a regular algorithm or regular software. So ML model is um, goes a little ahead in automating certain tasks that are where human intervention is needed. Talking about justification of implementing claims prediction model, which is the ML model we are discussing about. Claim processing costs. So on an average, 30 to $50 is the average cost of processing a claim in the insurance industry. And if it's a complex claim, it can go up to $300. This can be significantly reduced, costing millions of, so resulting in millions of dollars of profit. And then claim denial rates, 6% to 10% of healthcare claims are denied initially, and 30% of those denied are approved after rework. So reducing the denial rates by 5% could save hundreds of thousands of dollars annually. That's a huge amount. Reducing in the rework and appeals. Revenue impact. In the US healthcare industry, $262 billion in claims are denied annually. And then the impact of having the ML model in this case is lost revenue due to wrongful denials or delays are reduced. And there are other points like customer satisfaction. 39% of customers with denied claims are not satisfied. So we are having, at the end of the day, if the customer has to appeal for a claim, it's not a happy path. So fraud detection. So someone can misuse the existing process, and it could cost up to 40 billion annually. And the predictive models can flag these suspicious claims, improving the fraud detection, saving millions of dollars. Operational efficiency. Automating claims reviews via predicting models can reduce processing time by up to 50%. And then error reduction, 5 to 10% of claims are denied due to human error in manual reviews. Predicting claims approval likelihood, business requirement. So now the business requirement of the ML model. That's what we are going to discuss. As a revenue cycle manager, I want to utilize machine learning model to predict the likelihood of claim approvals or denials based on historical data, enabling me to identify potential issues early and take proactive measures to improve approval rates. Acceptance criteria here in terms of system requirements is the system should be able to accept diverse data, diverse claim features, patient demographics, submission date, service type, billed amount, historical status, and the prediction accuracy expected here is to achieve at least 85% of accuracy on the validation data sets for predicting claim outcomes. And then user interface is provide an intuitive dashboard for inputting claim details and viewing prediction results, including approval likelihood. Acceptance criteria when it comes to dashboard features what's the acceptance criteria from business point of view. Historical insights. So the user should be able to see historical insights, proactive alerts, and feedback mechanisms. Some kind of feedback mechanism should be able to feedback mechanism should be provided so that the user is able to provide some kind of a feedback on predictions, and this is what enhances the model performance. So the model is continuously trained, and user feedback is one of the data sets that is used for fine-tuning the model. And then proactive alerts, of course, we already discussed about this. When there is a risk of denial, the system should be able to flag it visually. And then historical insights. So user should be able to see what's the insight that ML model has come up with based on the historical claims data. Claims prediction model ML solution. So this is general overview of what the ML solution would look like for a claims prediction model. We first define a problem, and then I think this should be here. There's a little error. Data pre-processing happens after we define the problem and understand the objectives. We do the data pre-processing. So basically, we have huge amounts of different kinds of data. Data could be in CSV files, in tables. It could be in JSON, XML files. There could be different formats of data. We have to collect the data and do the pre-processing of data. And that involves cleaning the data. Cleaning the data is if there are any errors that have to be corrected, or if there is any error in the data set, if that has to be ignored, or that particular data has to be dropped. That is the cleaning of data. And feature engineering, and then categorical encoding. So encoding comes under normalization process. And then exploratory data analysis. At this point of time, after the data pre-processing happens, we could use some tools to do the data analysis. We could have some visuals to see how data looks like at this point of time. And then comes the model training. So this cleaned and pre-processed data is used for model training. And once the model is trained, it is deployed. This is the next stage. Model is deployed, and then after model is deployed, there's continuous monitoring. So monitoring and maintenance, that's the next phase. And then there's also model evaluation. So after model deployment happens, model evaluation needs to happen, which is where we use some data and test the model. And the confusion matrix is like the decision-making matrix. Let's say false positive, false negative, and then so true negatives and true positives, where the expected results are seen and expected results are not matching, or the actual results are not matching the expected results. That's the matrix here. Moving on. Claims prediction model with Azure ML. How we can implement claims prediction model on with Azure ML services or Azure ML tools, and resources. Implementing a claims prediction model on Azure ML provides a scalable, flexible, and secure environment for building, training, and deploying machine learning models. Of course, so Azure provides a platform for creating scalable, flexible, and secure services. And in this case, it's going to be our ML model. And then data ingestion and preparation. That's the first stage, where Azure provides powerful services to collect and prepare data before training your machine learning models. There's Azure Data Factory involved. So this is the pipeline. This is the data pipeline, where the data is pre-processed. And then, so Azure Data Factory is the one that orchestrates the entire data pipeline, ensuring that the data is ingested, processed, and transformed. And then using the ETL process, the data is extracted and it's fed into Databricks. Databricks processes and trains the machine learning model on the prepared data from ADF. So the data that's coming from ADF, it is fed into the Azure Databricks using the ETL processes. And the Azure Databricks is the one that provides a platform for model training. And then for further, if there is a further requirement of data processing, we can let it go through Pandas library, PySpark, and SQL, and finally fed into Azure Synapse Analytics. Now, Azure Synapse Analytics can provide the near instant insights into the data. This is especially useful for machine learning models that need to be fed with the updated data streams. So you can visually see how the data looks like using Azure Synapse Analytics. It's basically the data analytics so that you can analyze how the data looks like. Next comes feature engineering. For feature engineering, we could use Azure ML Data Prep SDK or Azure ML Designer. This way it is, you clean the data and then you normalize the data and you prepare the data. And here with Azure ML Designer, there are similar steps. Data wrangling is similar to cleaning the data, and then filtering, and then feature extraction, normalization. Normalization is either encoding or embedding, which is transforming the data or the text into numerical representation. Model training and development. Once the data is pre-processed, now the machine learning model has to be trained so that it's ready to predict the claim outcomes. Integrating, so Azure Machine Learning Studio is used here for training the model or developing the model. And what's involved in it, you could use integration with Python notebooks. You could use Python libraries for model training and development, and integration with scikit-learn or TensorFlow. And all of these are provided as libraries and tools in Azure, and integration with PyTorch, use of AutoML. Azure AutoML, and explores multiple models, identifies effective model here. Model evaluation and validation. Okay, so starts with Azure ML experimentation and then use evaluation metrics. Validate claims model, split the data set. Now splitting the data set is for testing. Data set is split, and each subset is used for testing the data model, or the machine learning model. And then you can visualize the test results on the metrics dashboard. And then that's the model performance. You can visualize the model performance, and then you could further fine tune the model and monitor the model drift. Model drift is if there is any discrepancy in the way the the output is given by the model. So you could see the discrepancy. This is all in the testing phase, and then do the fine tuning. Model deployment. Now this is the phase where model is deployed into the production. And this is where we are using the model in the real time for claims prediction. You could use Azure Kubernetes service or machine learning managed endpoints. There are a couple of options for us for model deployment. Model monitoring and feedback. And there's a general workflow. So after the model is deployed, of course, we need to monitor the model for performance and gathering the feedback. User feedback is one of the major data points that is used for uh, uh, model training and fine tuning. So through model monitoring and retraining, we are tracking the performance of the model, detecting the drift, So drift is nothing but any discrepancy, and then user feedback, and then automated retraining, integration with the data factory. What are the Azure tools and services that are used here? Azure Monitor, Azure ML model monitoring, Azure ML pipelines, application insights. These are some of the tools that can be used for model monitoring. You could write a Python code and incorporate application insights to get the telemetry, to get the real-time telemetry and track the key metrics to monitor the drift in the model performance. And lastly, key takeaways from this presentation. What are the enhancements that we can realize using the claims prediction model? How the AI-assisted claims prediction models improve the claims processing. Let's consider various factors here. Volume of claims pre-filtered. In the AI-assisted claims process, filters out simple claims, leaving only complex or suspicious ones for the secondary review. Advantage is reduces claims reaching secondary review by 50% here. Accuracy in identification. How the AI-assisted claims process helps. AI can analyze historical data to flag problematic claims accurately, reducing human error. And then advantage with AI, 5 to 10% reduction in wrongful denials and approvals due to higher accuracy. So paying attention to the numbers, they are huge difference. Speed of processing, manual review can take days or weeks, and AI speeds up processing by flagging the claims for review in seconds. And then up to 50% faster processing time. Secondary review burden. So the burden of secondary review is reduced. So some of these claims that need secondary review are cut down, and there is a 20 to 30% reduction in overall processing costs and improved throughput. And consistency in decision making. Sorry, just one second. Okay, consistency in decision making. AI models apply consistent criteria to every claim, ensuring fairer and more consistent decisions. Higher consistency and fairness, reducing bias and improving customer satisfaction. All right, that brings to the end of our presentation. Thank you.
Oh, sorry, I was on mute. So it is a
Yeah.
comprehensive presentation you have done it with a domain explanation, claims processing domain explanation, and later on for general ML without cloud, then later on about the Azure ML services usage for solution design. Everything is very clear
Yeah.
for taking this as a development project for claims processing. That's
Yeah.
where I could catch up from this.
Yeah.
Right. Let me stop recording.
So yeah. So before we stop, so this is the phase one presentation where we are only discussing
Okay.
the solution design steps, but the actual solution, how like the specific steps we are going to take for implementing this model or for developing this model is going to be the next phase, where I'll be explaining about more about the specific Azure tools or services that I'm going to use for data pre-processing and then model development, deployment, and testing, and all those activities.
Okay. In the phase two presentation, right?
Yeah.
Okay. Okay. Right. I'll stop.
Okay.